Hello everyone and welcome to this video in which I want to show you how you can calculate an intra-class correlation coefficient in Mplus along with a test of significance and confidence intervals. My name is Geiser. I'm an instructor and statistical consultant with QuantFish, and on this channel I present weekly statistics tutorials. I usually talk about multivariate methods including factor analysis, structural equation modeling, multi-level analysis and latent class modeling. If this is something that interests you, please subscribe to this channel. Also, check out the description for additional resources, including workshops that are offered through QuantFish. In this video, I want to talk about how to obtain a test of significance and confidence intervals for an intra-class correlation coefficient in the Mplus software. Now, first of all, what is an intra-class correlation coefficient and what is it good for? An intra-class correlation coefficient is often used in the context of multi-level data when you have, for example, students nested within classrooms or employees nested within companies, and you want to quantify the amount of variance that is at the between groups level. Also, the intra-class correlation coefficient is often used to quantify inter-rater agreement. And so it can be used for those purposes and also for other purposes. Oftentimes, we look at the intra-class correlation coefficient when we conduct multi-level models or we use hierarchical linear models to find out how large the dependency is of the observations on group membership. So when you have a large intra-class correlation coefficient, then this means that there are large differences, for example, between classrooms regarding mathematics achievement or other variables. And so here I want to show you an example of an intra-class correlation coefficient in the context of multi-level modeling where we have students nested within classrooms. And so first of all, how can you calculate an intra-class correlation coefficient in Mplus? You can do this in different ways, and I have a separate video on that topic. And so one way to calculate the intra-class correlation coefficient in Mplus is by using a two-level basic analysis. And then another way is to use a random intercept or intercept-only model of multi-level modeling. And that is the option that I'm going to use here to show you how you can also obtain a test of significance and confidence intervals for an intra-class correlation coefficient, which you would not get if you use the two-level basic option. So this is an input file here or syntax file for a very simple multi-level model where there's only a random intercept, no predictor variables at either level 1 or level 2, and this model is often called an intercept-only model or an unconditional cell means model because there's no predictor at level 2, or also an empty model, again because there are no predictor variables in this model. So this model simply serves to determine the level 1 and level 2 variance components that then can be used to determine the intra-class correlation coefficient, as we will see here. So let's get started and let's take a look at the Mplus syntax to see how we can obtain our intra-class correlation coefficient here along with a significance test and also with confidence intervals. You can see that in this data file here I have two variables: class, which indicates the school class membership, and then math is my outcome variable for which I want to calculate the intra-class correlation coefficient here for the students who are nested within classrooms. Then under use variables, I list my outcome variable math, and the school class variable is listed here as a cluster variable so that Mplus will be able to determine the two-level data structure so that it'll see how the groups are defined. Furthermore, under analysis, I specify type equals two-level, which tells Mplus that this is a multi-level model with two levels, the individual student level and the group level, meaning the level of the classrooms. In Mplus, the level 1 or individual level is referred to as within in a two-level model. So with this keyword within here, in between the percentage signs, we indicate that we're now specifying a model for level 1, the individual level. And here, so say I simply specified the name of the outcome variable, and then in parentheses, I provided a parameter label. That's how you label a parameter in Mplus in general, is by using a number or using string of letters in parentheses after a parameter, and then Mplus knows, okay, this parameter is labeled w_var for within variance or level 1 variance. And then I did the same thing also for the between level, which is the level 2 of the school classes here. And so this parameter, the between level variance, was labeled as b_var. So this is my between level variance component. Why did I label these parameters here? I did that so that I can then refer to those two variance components in the model constraint statement, which is next. The model constraint statement is used here to define a new parameter that we would otherwise not obtain. And in this case, this parameter is the intraclass correlation coefficient. So Mplus, although it gives you the intraclass correlation coefficient by default with a multi-level model, it will not by default give you a significance test or confidence intervals for that intraclass correlation coefficient. So if you want that, then you have to define the intraclass correlation coefficient manually as a new parameter, which then will be output by Mplus along with a standard error, test of significance, p-value, and also with confidence intervals if you ask for confidence intervals. So that's the reason why we have these parameter labels here and why we have the model constraint statement here. And so you can see that in the model constraint statement, I defined a new parameter and I labeled this parameter as ICC for intraclass correlation coefficient. So this is a label that I chose here. And so then Mplus knows, okay, there's supposed to be a new parameter labeled ICC. Now tell me, how is this parameter defined or how is this computed? Now, this is not really a new parameter in the sense that it's an independent parameter because it depends fully on those variance component parameters that have been labeled here and that are part of the model. So this is not really adding anything to the model. It's just using information, parameters from the model to compute this intraclass correlation coefficient. However, it is treated technically by Mplus as a new or additional parameter that in this case is a function of other parameters. And so you can see then that I entered the formula for the ICC here. The ICC in this multi-level model is defined as the between variance component divided by total variance. Total variance is the sum of within variance or level 1 variance plus between or level 2 variance. So that goes in the denominator. So I simply added this formula here so that the ICC would be output once more by Mplus along with a standard error, and so that I could also get the confidence intervals then. Now, the model constraint option is quite useful not just for this purpose, but also in other ways, and I have a separate video explaining the model constraint command in Mplus. If you're interested in that, it can also be used to, for example, enter non-linear parameter constraints that otherwise couldn't be specified easily. It can be used to define all kinds of additional parameters that are functions of model parameters, and so this is a very, very useful option in Mplus in general. Notice also that I added the C-interval subcommand to my output command here so that Mplus would also provide confidence intervals, and those confidence intervals then are provided also for the new parameters that are defined in model constraint, in this case for the intraclass correlation coefficient. So let's take a look at what the output here looks like in Mplus. You can see when we scroll down that we had 34 school classes. That's the number of clusters here. The average cluster size was about 15 students per school class. And then next is already the intraclass correlation coefficient for our math variable, which is here 0.44. And very substantial. So you can see that there's a very substantial amount of variance that is at the between level. 44% of the total variance is between level variance. Now notice that this ICC that Mplus gives us by default here, even without model constraint, we would get this value here, comes without a standard error, comes without a p-value. And so if you want that, then you have to add those commands here that we looked at previously, and we'll see where else we will find the ICC then with these additional with the additional information. So let's go down. You can see then next are the variance components. First for within, so here under covariances, this is the math variance at level 1, which is 26.48, and then the variance at the between level is 20.84, and so the 20.847 divided by 26.48 plus 20.847, that gives us the intraclass correlation coefficient. So this component here for the between level divided by total variance. Okay, we go down further, we can see that we get the variances again estimated here. So here's the within level variance again, here's the between level variance again, and then under new additional parameters we find our intraclass correlation coefficient again, 0.441, now given with a standard error 0.086, a test statistic 5.129, and also a p-value for the test statistic that is 0.000 something, so a very, very small p-value indicating that this intraclass correlation coefficient is statistically significant, which is not surprising given how large it is with a value of 0.44. That's a very large intraclass correlation coefficient that here shows us that there's a lot of differences between school classes, or in the school class mean math performance, the school class level, mean level math performance differs greatly between school classes. That's what this intraclass correlation coefficient tells us here. Now, below that, you can see that Mplus also gave us confidence intervals for the model results. So all the parameters, that the regular parameters that are output by Mplus, in this case the level 1 and level 2 variances, as well as the mean, are given here with confidence intervals. And you can see that the point estimate is in the middle, so that reproduces what we've seen previously in the output. So those values that are given here under estimate are the same ones that you find above under estimate under model results. And so then to the left and to the right of the middle point estimate column, we find lower 5% and upper 5%. So those would be the limits of a 90% confidence interval. So when you cut off 5% on one side and 5% on the other side, then you end up with a 90% confidence interval. Next are the limits of a 95% confidence interval. So this would be shown under lower 2.5% and upper 2.5%. Those are the limits of a 95% confidence interval, which is often what we are looking for, because that corresponds to a common significance level of 5% or alpha 5%. So you would look at those columns if you wanted a 95% confidence interval. And we can see that for our intraclass correlation coefficient of 0.441, the limits of a 95% confidence interval go from 0.272 to 0.609. So it's a fairly wide confidence interval. Of importance, this confidence interval does not include 0. So this means that the intraclass correlation coefficient is statistically significant at the 0.05 or 5% alpha level, which we have already seen based on the p-value here, which is a two-tailed p-value, and you can see it was smaller than 0.05. So we already saw that the intraclass correlation coefficient was significant at the 5% level. And we see that again from the 95% confidence interval, because this 95% confidence interval does not include 0. On the far left and the far right column, you find the limits of a 99% confidence interval. So here we have lower 0.5% and upper 0.5%. So together that's 1%, and so 100% minus 1% gives you a 99% confidence interval. And so you can see the 99% confidence interval reaches from 0.219 to 0.662, and again it does not include 0, showing that the intraclass correlation coefficient of 0.441 is significant also at the 1% significance level. So the p-value, as we saw, is not only smaller than 0.05, it's also smaller than 0.01. So it's significant also at the 1% level. I hope you found this video useful to learn about how you can calculate a significance test and confidence intervals for an intraclass correlation coefficient in the Mplus software. If you did, please subscribe to this channel. Don't forget to check out the description for additional resources, and I'll see you next time.